Now, Newton's first law states that if there is no net force acting on the object, in that case, its velocity will not change. If it is at rest, it will stay at rest. If it has a non-zero velocity, it will move with a constant velocity. But what happens if there is a net force acting on the object? And well, from our everyday experience, we know that if, let's say that if you take an object that has a small mass, you can just cause it to accelerate quite easily. But if the object is very much heavier, just imagine a car. If you exert the same force that you exert on this one, then the car will not really even move from its position. So you can just see that somehow the force is one thing, it's related with the acceleration. Any object that is at rest, it will start accelerating in the direction that you push them. So the direction of the force and acceleration is related. And furthermore, the mass of the object is, the harder it will be to accelerate it, to change its velocity. Now, Newton through observation, he saw that the acceleration of an object, whether it is at rest or in motion, is always given by the net force acting on the object divided by the mass. So here the sign over here shows the sum of the forces acting on the object. So this symbol means the net force acting on the object. And the acceleration is always in the direction of the net force and inversely proportional to the mass. So you can also write this equation as the net force acting on the object is always the mass of the object multiplied by the acceleration. Or in terms of the components, since we have two vectors that are equal to each other, the sum of the x component of the forces acting on the object, or the x component of the net force acting on the object, will be equal to the mass times the x component of the acceleration. Similarly, the sum of the y components will be mass times the y component of the acceleration, and sum of the z components of the force will be the mass times sum of the z components of the acceleration. Since these are both vectorial quantities, we have these relationships between the components and the accelerations themselves. The unit of force can be read from here. The unit of the mass is kilogram. The unit of acceleration is meters per second squared. So the unit of force is kilogram meters per second squared, which is also called Newton. So the unit of the force is 1 Newton. Now this relationship, if you remember what we had discussed in kinematics, we started from the position of the object. We described the changes in the position of the object using what is called the velocity. So the changes in the position is described by the velocity of the object. And then changes in the velocity of the object is described by the acceleration of the object. But in principle, we can also look at the changes in the acceleration of the object. But that is not necessary because you see the acceleration is determined by the forces acting on the object. So once we know the forces acting on the object, we can determine the acceleration of the object. Once the acceleration is determined, we can determine the velocity of the object as a function of time. And once the velocity is known, we can determine the position of the object as a function of time. So it's enough to define the acceleration as a kinematical variable.